Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Galpur. Today, our topic molarity, normality, and colloids. These topics belongs to first year diploma student, common subject for first semester student, subject code SC 104. So in this hour we discuss about what is molarity, how to calculate the molarity of given solution, what is normality, calculation of normality of given solution, colloids, what is colloid, how many types of colloids available, what are the applications of colloids, discuss about this hour. Objectives. On the completion of this period, you would be able to know the completion of this period, you would be able to know molarity, normality, calculation of molarity and normality, colloids, types of colloids. In this hour, we discuss about topics molarity, normality, calculation of molarity and normality, colloids, types of colloids. Types of colloids. Molarity. Already last class we discussed about what is mole, how to calculate the mole of solution. Now we discuss what is molarity, how to calculate the molarity of given solution, what is normality, calculation of normality of given solution by using formulas. Colloids. What is colloid? How many types of colloids? What are the applications of colloids? So we discuss in this hour. Way of expressing concentration of solution molarity. Way of expressing concentration of solution in molarity. What is concentration? The weight of solute particles present in unit volume of solution is called concentration. How many grams of solutes dissolve in given water solution or unknown solution is called concentrated solution. These concentrations are calculated by molarity and normality. So, the concentration of solution we expressed in terms of molarity. The concentration of solution can measure by using molarity. Molarity is the number of moles of the solute contained in 1 liter of solution. Is the number of moles of the solute contained in 1 liter of solution is called molarity. What is a concentration? The quantity of solute. The quantity of solute present in definite amount of a solution is called its concentration. The quantity of solute present in defined unit amount of solution is called its concentration. The concentration represents the composition of the solution. In other words, it indicates the relative amount of solute and solvent. A solution whose concentration is known exactly is called standard solution. A solution whose concentration is known exactly is called standard solution. So, the concentration of solution can express in terms of molarity. What is molarity? The quantity of solute present in defined amount of solution is called concentration. A solution containing small amount of solute present in solvent is called dilute solution. The concentration of dilute solution is very low. The concentration of solution is expressed in the following ways: molarity and normality. Molarity. What is molarity? The common method to express the concentration of a solution is molarity. What is molarity? The number of moles of solute. The number of moles of solute present in 1 liter of solution at given temperature is known as molarity. The number of moles of solute present in 1 liter of the solution at a given temperature is known as molarity. What is molarity? The number of moles of solute present in 1 liter of the solution at a given temperature is known as molarity. A solution containing 1 mole of solute in 1 liter of solution is called 1 molar solution. A solution containing 1 mole of solute in 1 liter of solution is called 1 molar solution. 1 molar solution. What is a mole? Mole is the quantity of the substance that contains Avogadro number of particles is called mole. What is Avogadro number? 6.023 into 10 to the power of 23 particles or atoms or molecules is called mole. Or the amount of the substance containing the same number of particles as the number of atoms present in 12 grams of carbon C12 is called mole. The particles of Avogadro present of the substance is called mole. Mole can measure by using formula weight of the substance by gram molecular weight of substance. Weight of the substance by gram molecular weight of substance. Then the number of moles of solute containing 1 liter of solution is called molar. If 0.1 moles solute dissolved in 1 liter of solution is called 0.1 1m solution. How to calculate the number of moles present in the solution? Formula: molarity is equal to number of moles of solute by volume of solution in liters. Molarity of a solution is calculated by the following equation. Molarity is equal to number of moles of solute by volume of solution in liters. So, molarity is denoted by capital M. Number of moles is denoted small n. Volume of solution V in liters. Therefore, molarity capital M is equal to small n by V in liters. So, molarity of solution is equal to number of moles of solute by volume of solution in liters. Therefore, capital M is equal to small n by V in liters. N is equal to number of moles by volume of solution in liters. But number of moles small n is equal to weight of the substance by gram molecular weight of substance. Therefore, small n is equal to W by GMW. Therefore, capital M is equal to W by GMW into 1 by V in liters. In case volume of solution in milliliters, therefore molarity capital M is equal to W by GMW into 1000 by V in milliliters. Therefore, capital M is equal to W by GMW into 1000 by V in milliliters. Molarity. Molarity M is expressed as moles of solute per liter of solution. Molarity describes concentration in terms of volume of solution. Volume of solution, not volume of solvent. Molarity describes concentration in terms of volume of solution, not volume of solvent. Therefore, molarity is equal to moles of solute by liters of solution. Liters of solution. Therefore, molarity M is equal to number of moles of solute by volume of solution in liters. So, here given problem, what is the molarity of a 0.4 moles of NaCl dissolved in 0.25 liters of water? Calculate the molarity of given problem. What is the molarity of a 0.4 moles of NaCl dissolved in 0.250 liters of water? So here molarity capital M is equal to number of moles by volume of solution in liters. Given data, number of moles small n is equal to 0.40, Volume of solution in liters 0.250 liters. So molarity M is equal number of moles small n by volume of solution in liters V in liters. Small n is equal 0.40. Volume of solution in liters 0.250. Therefore molarity M is equal small n by V in liters. Small n is equal 0.40 by 0.250 volume of solution in liters. So 0.40 by 0.250. 250. Then 0.40 by 0.250, that is equal 1.6 m. 1.6 m. Now normality. Normality the strength of solution measured in terms of gram equivalent per liter is called normality. The strength of solution measured in terms of gram equivalent per liter is called normality. It is denoted by capital N. It is denoted by capital N. A solution having 1 gram equivalent of the dissolved solute in 1 liter, its solution is called normality. What is equivalent weight? The weight of the substance. The weight of the substance that react with 1 gram of hydrogen or 8 grams of oxygen is called equivalent weight of the substance. The weight of the substance that react with 1 gram of hydrogen or 8 grams of oxygen is called equivalent weight. The substance that react with 1 gram of hydrogen is equal to 1 equivalent weight. So, the number of equivalents present in liters is called normality. What is normality? The strength of solution measured in terms of gram equivalents per liter is called normality. What is equivalent? The weight of the substance that react with 1 gram of hydrogen or 8 grams of oxygen is called equivalent weight. It is denoted by capital N. A solution having 1 gram equivalent of the dissolved solution in 1 liter of its solution is called normality. So, normality, the number of gram equivalent of solute. The number of gram equivalent of solute present in 1 liter of solution at a given temperature is called normality. Therefore, normality capital N is equal number of gram equivalent weight of solute by volume of solution in liters. Therefore, capital N is equal number of gram equivalent, that is capital E, by volume of solution in liters, V in liters. V in liters. Normality expressed as a ratio of the amount of solute to the total amount of solution. Normality expressed as a ratio of the amount of solute to the total amount of solution. Normality, it is defined as the number of equivalent. It is defined as the number of equivalent of the solute, gram equivalents of solute present in 1 liter of solution. Present in 1 liter of solution. Therefore, concentration of solution is equal amount of solute by total amount of solution. That means the number of gram equivalent weight of solute by volume of solution in liters. Volume of solution in liters. Therefore, concentration of solution calculation, how much amount of solute present in given solution by total amount of solution. Total amount of solution. Calculation of equivalent weight. Calculation of equivalent weight of different compounds, acids, bases and salts. So, equivalent weight of an acid, it is the ratio of molecular weight to its basicity. It is the ratio in between molecular weight of acid and its basicity. So, equivalent weight of acid is equal molecular mass of the acid by basicity of the acid. Equivalent weight of acid, E acid is equal molecular weight of acid by molecular weight of acid by basicity of the acid. Basicity of the acid. What is basicity? Basicity is the number of displaceable hydrogen atoms present in an acid. Basicity is the number of displaceable hydrogen atoms present in an acid. Basicity is the number of displaceable hydrogen atoms present in an acid. So here basicity means the number of displaceable hydrogen ions in 1 mole of an acid is called basicity. So here some example, hydrochloric acid, it give only 1 H plus ion, so basicity of HCl is equal to 1. So HCl gram molecular weight, equivalent weight is equal, gram molecular weight is equal 36.5, basicity is equal to 1, that is equal to equivalent weight of HCl is equal 36.5 by 1, that is 36.5. Sulfuric acid, basicity is equal to gram molecular weight of sulfuric acid is equal to 98, basicity 2, that is 98 by 2. that is equal to 49. So how many number of H plus ions replaced from the substance is called basicity. Now base equivalent weight. Calculation of equivalent weight of a base. It is the ratio of molecular weight to its acidity of base. It is the ratio of molecular weight of base and its acidity. Therefore, equivalent weight of base is equal molecular weight of the base by acidity of the base. Acidity of the base. What is acidity? The number of replaceable OH minus ions in 1 mole of an base. What is base? The substance produce OH minus ions in aqueous solution is called base. NaOH, it produces OH minus ions. KOH produce OH minus ions. The number of OH minus ions is called acidity. The number of replaceable OH minus ions in 1 mole of an base is called acidity. Therefore, sodium hydroxide gram molecular weight 40, acidity is equal to 1, equivalent weight of sodium hydroxide is equal to 40 by 1, that is equal to 40. Magnesium hydroxide gram molecular weight 58, its acidity is equal to 2, therefore equivalent weight of magnesium hydroxide is equal gram molecular weight 58 by acidity of magnesium hydroxide to 8 is given to OH minus ions to the other substance is called acidity. That is equal equivalent weight of magnesium hydroxide is equal to 58 by 2, that is 29. Molarity is a concentration unit that describes how much of substance is dissolved in solution. Therefore, molarity is equal moles of solute by liters of solution. Liters of solution. Therefore, M is equal number of moles by volume of solution in liters. Volume of solution in liters. So, molarity given one problem. What is the molarity of a 250 ml of solution containing 0.35 moles of NaCl? So, these 250 ml convert into liters. Therefore, 250 by 1000, 250 ml by 1000 ml, that is equal 0.25 liters. Now calculation of molarity of solution. Molarity is equal number of moles of solute by volume of solution in liters. Given problem, sodium chloride number of moles is equal 0.35 moles, sodium chloride volume in liters 0.25 liters. Therefore, 0.35 moles of NaCl by 0.25 liters of solution, that is equal 1.4 m molarity of solution. Another problem. Suppose we have 35 ml of 0.85 m magnesium chloride solution. How many moles of magnesium chlorides are present in the solution? 35 ml of 0.85 m magnesium chloride solution are available. How many number of moles of magnesium chloride are present in the solution. 35 ml of solution convert into liters. So 35 by 1000 ml, that is equal 0.035 liters. Now rearrange the molarity equation and solve the number of moles. Number of moles, how much? Therefore molarity M is equal number of moles by volume of solution in liters. Given data of magnesium chloride, number of moles of solution 0.85 molarity, volume of solution in liters 0.035 liters. Calculate the number of moles of solute, small n is equal to how much? Therefore molarity M is equal small n by volume of solution in liters. Therefore number of moles is equal molarity into volume of solution in liters. Molarity 0.85 m into volume of solution in liter 0.035 liters. So number of moles 0.03 moles of magnesium chlorides. The 0.03 moles of magnesium chloride particles present in 35 ml of 0.85 m solution. How many milliliters of a 1.2 m magnesium chloride solution are needed to have 0.35 moles of magnesium chloride? So molarity 1.2 m, number of moles 0.35 moles. Calculate the milliliters of solution. Rearrange the molarity equation, number of moles by volume of solution in liters. So here molarity M is equal number of moles by volume of solution in liters. So volume of solution V in liters is equal molarity number of moles by molarity of solution. So number of moles 0.35 by molarity of solution 1.2. So volume of solution in liters 0.29 liters. We convert into milliliters 0.29 by 1000, that is equal 290 ml of magnesium chloride present in 1.2 m of 0.35 moles of magnesium chloride solution. Dilution solution. How many milliliters of 25 m HCl stock solution would we need to make 100 ml of 0.8 m solution? Therefore, dilution law M1V1 is equal M2V2. Mn 2.5 m into V1 is equal 0.80 into 100 ml. Therefore, V1 is equal 0.80 into 100 by 2.5 m, that is equal 32 ml. So 32 ml of 0.25 m is equal 100 ml of 0.80 m HCl solution. Dilution is the process of adding solvent to a more concentrated solution to yield a solution of lower concentration. The equation for dilution calculation is M1 V1 is equal M2 V2, where M1 is the initial molarity, V1 is the initial volume, M2 is the final molarity of solution, and V2 is the final volume of solution. This one is dilution law of given solution. See here one problem. What is the molarity of 1N H2SO4 solution? In this case, N factor is 2. That means density is equal to, therefore molarity is equal to 1 by 2. That is equal to 0.5 M solution. What is the normality of a solution of H2SO4 having a molarity of 0.1 M solution? N factor is 2. Normality is equal N factor into molarity, that is equal 2 into 0.1, that is 0.2 N solution. Now colloids. What is a colloid? A colloid is a substance microscopically dispersed through the and other substance. It is a microscopic dispersed through another substance. Colloid, a heterogeneous system in which one substance is dispersed as very fine particles in another substance is called dispersion medium. So, a colloid system contains two components, dispersed phase and dispersion medium. So, the word colloid comes from a Greek word kolla, which means glue. Thus, colloidal particles are glue-like substances. These particles pass through a filter paper but not through a semi-permeable membrane. Colloids can be made setting by the process of centrifugation. As we know, a solution is composed of solvent and solvent. The particles of solution are usually at the normal molecules or ions. The size of particles between 1 to 10 angstrom, which are invisible in our naked eyes. When substances such as clay or sand are put water, particles settle down and standing more time. These are called suspension, in which particle size greater than 2000 angstrom. In between 1 to 10 angstrom, solute particles is called solution. This mixture is called homogeneous mixture. The sand and water molecules, those are sand particle sizes 2000 angstrom. A colloid solution is prepared with an substance by making use of suitable methods. The size of particles in colloid solution in between 10 angstrom to 2000 angstrom. These particles are visible particles, so this mixture is called heterogeneous mixture. Two components are present, one is dispersed phase and another one is dispersion medium. In colloidal solution present two components, one is dispersed phase and another one is dispersion medium. Dispersion phase. What is dispersion phase? The substance which is dispersed as colloidal particles in dispersion medium is called dispersion phase. The dispersed phase particles have a diameter of between approximately 1 nanometer to 100 nanometers. Such particles are normally invisible in an optical, so their presence can be confirmed with the uses of ultra microscope or an electron microscope. And dispersion medium. What is dispersion medium? The substance which another substance is present as colloidal particle is called dispersion medium. So, in smoke, solid carbon particles are dispersion phase, air dispersion medium. The gaseous medium is dispersion medium. In milk, dispersion medium is water and dispersion phase is liquid fat particles. Salts means solid in liquid type of colloids are called salts. Now, based on nature of interaction between dispersion phase and dispersion medium, colloids are two types. One is lyophobic colloids, second one is lyophilic colloids. What is lyophilic? Colloidal solution in which the dispersed phase has a greater affinity for the dispersion medium. They are also termed as interaction between colloidal particles. Such substances have tendency to pass into colloidal solution when brought in contact with dispersion medium. If the dispersion medium is water, they are called hydrophilic or emulsions. The lyophilic colloids are generally self-stabilized and some particles of reversible in nature and have heavily hydrated. Example of lyophilic colloids are starch, gelatin, rubber, protein, etc. Lyophobic colloids. Colloidal solution in which the dispersion phase has no affinity to the dispersion medium. There are also referred as extremely colloids. Such substances have no tendency to pass into colloidal solution when brought in contact with dispersion medium. The lyophilic colloids are relatively unstable. They are irreversible by nature and are stabilized by adding small amount of electrolyte. They are purely hydrated. If the dispersion medium is water, the lyophilic colloids are called lyophobic or suspensions. Example, salts of medium like iron salt, silver salt, of metals, hydroxides of solutions, of metals, sulfides. These two types of colloidal solutions, one lyophilic and lyophobic colloids. So in this hour we discuss about what is molarity, how to calculate the molarity of given solution by using formula molarity n is equal number of moles by volume of solution in liters. Therefore small n by V in liters. N is equal to weight of the substance by gram molecular weight of substance into 1 by V in liters. So in case given solution volume in milliliters, therefore M is equal to weight by gram molecular weight into 1000 by Vm. What is normality? The number of gram equivalents present in 1 liter of solution is called normality. Therefore N is equal equivalent weight by volume of solution in liters. Therefore N is equal to capital E by V in liters. Capital E means equivalent weight of the substance. What is equivalent weight? The weight of the substance that react with 1 gram of hydrogen or 8 grams of oxygen is equal to equivalent weight. Acid equivalent weight is the ratio between gram molecular weight and its basicity. Base equivalent weight, the ratio between gram molecular weight and its acidity. Thank you once again.